Hey guys, welcome to question MM350 of the Maths Methods Fortify study guide. So in this question we've got two graphs. We've got g of x equals x squared and h of x equals x squared over 2 plus 2x plus t, as shown below on this graph here. Now, the graph of h is sliding upwards at a rate of 1 unit per second, such that t is equal to both h of 0 and the time in seconds since the graph started sliding upwards. Okay, so this graph h of x has started at the bottom, right? So when t is equal to 0, this y-intercept here would have been down here at 0, and it's sliding upwards at a rate of 1 unit per second. Okay, the points a and b are the points of intersection between y equals g of x and y equals h of x. Find the coordinates of points a and b in terms of t. Awesome. So a and b are the points of intersection, which means we're going to have to find g of x is equal to h of x, right? That's always our point of intersection formula there. So that means that x squared is equal to x squared over 2 plus 2x plus t, which means that 0 is equal to negative x squared on 2 plus 2x plus t, which is our first mark. So equaling those gets us our first mark. And then to solve for x, we're going to need to use our quadratic formula. Okay, so this bit here is our a, this is our b, and this is our c, where x is equal to negative b plus minus square root of b squared minus 4ac over 2a. And so that means that x is equal to negative 2 plus minus the square root of 2 squared minus 4 times negative a half times c, which is t. Awesome. Over 2a, where a is negative 1/2. So 2 times negative a half. Awesome. What this eventually gets us is x equals 2 plus minus square root of 4 plus 2t. Awesome. And this is our second mark, okay? Now, our third mark comes from actually stating the coordinates. So we've got our x values, but we need our y values, and we need to state the coordinates of a and b now. So that means that we need to sub in our these values for x in one of these. So g of x equals x squared. So g of 2 plus root 4 plus 2t is equal to 2 plus root 4 plus 2t squared, which is equal to 4 plus 4 plus 2t plus 4 plus 2t. Awesome. Which gives us, let's have a look-see. Awesome. Which is 8 plus 4 plus 2t plus 2t. Awesome. Fantastic. And now what we can do is plug in our other value of x. So we get 2 minus 4 plus 2, root 4 plus 2t, which is equal to 2 minus root 4 plus 2t squared, which gives us 4 minus 4 root 4 plus 2t plus 4 plus 2t, which gives us 8 minus 4 root 4 plus 2t plus 2t. Sweet. So therefore a is, as a simplified version, 2 minus root 4 plus 2t. 2 outside of 4 take 2 root 4 plus 2t plus 2t, plus t. I've just taken 2 out as a common factor there. And b is 2 plus root 4 plus 2t, 2 outside of 4 plus 2 root 4 plus 2t plus t. Fantastic. And that's it for this question. So that's our third mark right there. And our second mark comes from getting our x values, which I mentioned, and that's it. So just this bit here is our third and final mark. Guys, that's it for part AI. Let's move on to part AII. Part AII is a 2-mark question, and we're going to need to find the area, a unit squared, of the shaded region above bound by the graphs of y equals g of x and y equals h of x in terms of t. So we're finding this area here, and in theory it's pretty straightforward because we're just finding the area between two graphs. So we're finding the area between h of x and the area between g of x, which means that we're doing the area from a to b of the top function, which is h of x, minus the bottom function, which is g of x dx. Awesome. Now our ax value is 2 minus 4 plus 2t, and then 2 plus root 4 plus 2t. H of x is equal to x squared on 2 plus 2x plus t, and then we're minusing our g of x, which is x squared, so minus x squared dx. This gives us our value of negative x cubed on 6 plus x squared plus tx from 2 minus root 4 plus 2t, 2 plus root 4 plus 2t. So you can just chuck this into your CAS and get to this next point here. This is your first mark, okay? And then what we need to do from here is just evaluate this. So what we end up getting is negative 2 plus root 4. This is going to be very long, actually. I'm just going to rub this out. So if you need to write this down, just write that down now, and then follow along with me now. So what we're going to get here is area is equal to negative 2 plus root 4 plus 2t to the power of 3 over 6 plus 2 plus root 4 plus 2t squared plus, I'm just going to go down here, plus t outside of 2 plus square root 4 plus 2t. That's that. And then we're going to minus, subbing in our other value, so 2 minus root 4 plus 2t. So then minus negative 2 take root 4 plus 2t cubed over 6, then plus 2 take root 4 plus 2t squared plus, go down here, plus t outside of 2 take root 4 plus 2t. Wow. Alrighty, so from there, you just put this in your calculator because that'll be the easiest thing to do. So then from here you get a equals 4 root 2 outside of t plus 2 to the power of 3 on 2 over 3 units squared. Awesome. Now your first mark was when you anti-derive the function, and then our second mark is our area here. So that's our area there. Guys, that's it for part AII. If you have any questions, let me know, but let's move on to part B now. Part B is simply a 1-mark question and asks us to find, or actually tells us, 2 seconds after the graph of h begins its upward slide, the shaded region above is equal to k units squared. Find the exact value of k. Awesome. So at t equals 2, area equals k. We know that the area is equal to 4 root 2 t plus 2 to the power of 3 on 2 over 3. So a of 2 is equal to 4 root 2 outside of 2 plus 2 to the power of 3 on 2 over 3. So 4 root 2 outside of 4 to the power of 3 on 2 over 3. Now you've got your CAS, so you can do this in your calculator, and what you'll get is 32 root 2 over 3 units squared. That's our first and only mark for this question. You don't need to show any working because it's just a 1-mark question, but I just did that for your sake. That's it for part B. Let's move on to part C. Part C is a 2-mark question and asks us to find dA dt, which is the rate of increase of the shaded area over the rate of increase of the area of the shaded region over time. Awesome. So we know that A is equal to 4 root 2 t plus 2 3 on 2 over 3. Now I'm just going to break this up into 2 sections. So we've got 4 root 2 over 3, so just this bit here, times t plus 2 to the 3 on 2. So now what's going to happen, dA dt is going to be equal to 4 root 2 over 3. That just stays the same because it's a constant. We're going to minus 1 from this power. And, sorry, we're going to multiply the front by the power. So times 3 on 2. We're going to times the front by the coefficient of t as well. In this case, it's just 1, so we have times 1. And then we times it by this and minus 1 off the power. So what we end up getting, that's actually our first mark there. What we end up getting is 2 root 2 times t plus 2, which gives us 2 outside of 4 plus 2, root 4 plus 2t. dA dt is equal to this. This is our second mark. So guys, that's it for part C. Let's move on to part D. So part D says the value of t for which, find the value of t for which the rate of increase of the area of the shaded region is log e of 2 units squared per second. And so we know that dA dt is equal to 2 root 4 plus 2t. And we know that we're looking for the rate of increase when it's log e of 2 units squared per second, which means that log e of 2 equals 2 root 4 plus 2t. And then from there, we can just simply solve for t. So divide both sides by 2. You can do this on your CAS because it's just a 1 mark question. Log e of 2 over 2, and then we can square both sides to get rid of that square root, and that is going to equal to 4 plus 2t, which means that 2t is equal to log e of 2 squared over 4, so I've just done 2 squared there, and minus 4, so this minus 4 is on the other side, so then t is equal to log e of 2 squared over 8 minus 2, seconds. This is our first and only mark for part D. Guys, that wraps up MM350 and the whole integration section, so congratulations if you've made it this far. If you have any questions about any of these questions, or this one in particular, please hit me up in the comments below, and I'll see you in the next video. Thank you very much for watching.